Hello, my lovelies. It's Susanne, and today I want to show you how to find out which number is larger, this number or this number. And these numbers are huge, so maybe let's take a look at way smaller numbers first. For example, 10 and 5. How could we find out here which number is larger? One way to do it is to take one number, the 10 in this case, and just divide it by the other number. And if this fraction is greater than 1, then this number is larger than this number. If this fraction is less than 1, then this number is smaller than this number. In the third case, it could also be equal to 1, of course, but then both numbers would be equal, so we would have 10 over 10. Of course, it's possible, so we have to check which of these cases we get in this example here. So even if these numbers are huge, we can use the same thing. We take one of these numbers, the 222 to the power of 333, and divide it by the other number, the 333 to the power of 222. And now we have to find out, is this fraction greater than 1 or less than 1? Or, okay, equal to 1. Okay, what can we do here? If we take a look at the numbers and maybe the bases first, so if we compare these two, can we find some similarities here? Both numbers have a common factor. The 111 is part of this number and of this number. So we can write this number here as 2 times 111, and then we still have to raise it to this power, so let's write it in parentheses and raise it to 333. And the same thing here, we can write this number as 3 times 111, and then we also have to raise it to this power to 222. Now we have this number here and here. What can we do now? We could get rid of the parentheses here. We have a multiplication here, which means that we can apply this exponent to the first part and then also to the second part. So we have 2 to the power of 333, beautiful numbers, times 111 raised to this power here. And the same thing here. We have a multiplication, so let's apply this exponent here first. So we have 3 to the power of 222 times, and then the same thing with the 111 to the power of 222. Okay, this is what we have so far. Now we have base 111 here, same base here, which means that we can simplify these powers here. So maybe let's write this one big fraction as 2 separate fractions so that we can take a look at this here separately. We have a multiplication here and here, so these fractions are multiplied by each other. We take these 111 bases here with this power and the same base down here with another power, and we take these and write them down here, one with base 2 and the other with base 3. Okay, maybe we start here where we have the same bases because there is a rule what we are allowed to do here. If you have something like a to the power of x over a to the power of y, you can simplify this by taking the base, your a, and then you subtract the exponents. So you take x minus y, which means in our case, we take the base, the 111, and subtract our exponents. 333 minus 222 is equal to 111. What about the first fraction? Here we cannot see 111s yet, but we know that they are part of this number here and of this number here as well. So let's write this power here as 2 to the power of 3 times 111. And the same thing here, we have the base 3 and write this as 2 times 111. Because now we can see the 111 here, here, and here. Here it is the exponent. Here, not really. We have 3 times this number and 2 times this number. So I would love to just have 111 as an exponent here as well. But there is a rule what we can do to get this, because we have a multiplication here. So we have something like a to the power of x times y. And then there is a rule that tells us that we can write this as take the base, a, raise it to the power of x first, and then raise all of this to the power of y. So let's write this fraction then like this, where we take the base, the 2, raise it to the power of 3 first, and then raise all of this to the power of 111, because now this is our exponent. The same thing down here. We take the base, raise it to the power of 2 first, and then raise all of this to the power of 111, where we have this as exponent. And here we still have this power with this exponent here. And now these numbers are so small that we can calculate them. 2 to the power of 3 is 2 times 2 times 2, which is 8. So I'm going to erase this and write down 8. We don't need these parentheses then anymore, so I'm going to erase them here as well. And here we have 3 to the power of 2, which is 9. So I'm going to erase all of this and write down a 9. Okay, now we have the same exponents everywhere. We have a multiplication here. There is a rule if you have the same exponents, what you are allowed to do. So if you have something like a to the power of x times b to the power of x, same exponent, multiplication here in between, then you are allowed to write the bases in parentheses, so a times b, and then raise all of this to this same exponent. So let's apply this rule here now. We take all the bases and write them in parentheses. So we have 8 here. We divide it by 9 and multiplied by 11, and then we take this exponent that was the same here everywhere and write it down here. Okay, now the numbers in here are so small that we can calculate them. We have 8 times 111, which is 888 divided by 9, and we have this exponent. We wanted to find out if this number is greater than 1 or less than 1. We can say that now. In here, this fraction, 888 divided by 9, I don't know what it is exactly, but I definitely know that this is greater than 1. And if I have something that is greater than 1 and I raise it to the power of 111, then this entire thing stays greater than 1, which means that when we go back to the beginning, the fraction we had is greater than 1, which means that this number is larger than this number. And that means that this number wins. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!